Hi. Yay. Well, this is another Google Summer of Code project. Unfortunately, at the same time, this right moment, and the fourth Google Summer of Code that was done here in Argentina is being presented in the other room. So, well, I guess you will have to see 3 out of 4, maybe. But, well, this project was about UML and diagrams, and now we will see a bit of that. My mentor was Stefan, and my commenter was Git. And well, that's it. Let's see. Okay, so why did I choose to do this? A lot of you are like great programmers and professional and everything, but I smell sometimes that people more newbies like me, for example, don't pay attention to documentation, and sometimes we get hurt at the end because we didn't do that. So why don't we document using diagrams? It's common to hear that Smalltalk has clean and understandable code, so we don't need diagrams and all that stuff because we just can read the code and that's it. Another thing is that the code itself is a documentation. It's kind of the same thing. UML is for managers, not for developers. And, well, okay, it's boring. Documenting is boring. But we can think a little bit about these things. Like, for example, okay, Smalltalk has clean, understandable code, but you have to trust the person who is coding in Smalltalk. I have seen horrible code written in Smalltalk. Believe me, horrible. So maybe using a diagram helps to understand what was thinking the person that wrote that. What is the solution behind that code? In this case, okay, the code itself can be the documentation, but sometimes it's just easier to see the big picture. In a big system, just reading code can maybe take a lot of time. So having diagrams can help understanding faster. UML is for managers. Well, UML is for communicating, actually, or diagrams. General diagrams are for communicating, so it can be useful for both managers or developers or anyone who needs them. And it's boring. It can be, well, yeah, it's boring. So we have documentation. Another case. Do we always read it? We don't have time. We don't read it. Or we don't even know it exists. That happens to me a lot. And okay, it's boring. Well, why we say we don't have time? Because maybe we are very anxious to start coding or start using the project that we just loaded, and we don't have time to spend reading so much pages about blah blah blah. We want to go to the game. In this case, maybe we don't know that documentation exists because we loaded the code and didn't pay attention to anything else. It's like, okay, now I am in my image, I am with my code, and that's my word. It's boring. Okay, yeah, it's boring, but maybe if the documentation is right, you can start playing with the code sooner. So, what's this project about? It's a little project to help us document and communicate important design ideas. It's not necessary to document maybe all the system, just at least the key parts of it, the very important design decisions. And the idea is to keep it simple, and hopefully it won't be so boring. Really? Not just boring manager stuff? Nope. When we are using small UML, diagrams are described through code. They are built through code and are saved as methods. So this allows us to do nice things like share them via Monticello. They are not just pretty images. We can merge them when we use Monticello. We can edit them through code, and we can keep versions of the diagrams, like code, actual code. For example, this is a screenshot that I took from one of the diagrams I will show you later. This diagram is actually this code. Every diagram is saved as code. You can see that this is the description of what we are looking. It doesn't matter if you can read this. Here are the relationships between the class boxes. For example, the connectable bounding box here implements this interface. Or the connectable bounding box has lots of connectable border. And in this way, we can build the diagrams. So, a few key points of this project. The important thing is not to respect the UML syntax and all the rules that it has. It doesn't have to be UML compliant. The thing is that diagrams must help me to communicate. In the moment that they don't help me to communicate, they are not so useful anymore. So I want to be comfortable when I want to communicate things. So, for example, this project has cute style for diagram nodes, for class boxes, for example. It's not the usual UML box style. Especially, for example, this one is an interface or a type. On the other hand, we can have comfortable additions to what we really need. For example, I didn't find anything that would tell me how to draw traits respecting the UML rules. So I just chose a way to document traits, because it would be great that if we have traits, we communicate that design decision. So it's flexible. We don't have to use UML like the book say. Okay, so now a little demo. And while I am showing you this, you will see the features. Yay, demo. For the first demo, I chose to grab an example that we use in college for students. It's about pirates. It was actually an exam that we took last year. Here I have some classes. I have a pirate that can be part of a ship, and the ship has a mission, like becoming a legend or a robbery or a treasure quest. Well, we will see about that. There's not actually much code. It's just for showing you how this works. Now, I want to document this category using Pharo, of course. I forgot to mention that. So, what do I have to do? Unluckily, there is no OB integration with this project yet. So some things have to be done like by hand. I can't, unluckily, do a right click and create documentation and do it that way. I will have to create a new class that inherits from category diagrams holder. A diagrams holder is a class where diagrams will be saved as methods, as I said before. And I will call this parrots documentation. Okay. So now that I have this class, I can go to a workspace and just ask to that class to open a diagram browser. And this is a diagram browser. It's not let me see. Okay, here I am. Okay, so in this pane, I will have listed the diagrams that I will be building inside this category. And here is the pane where I'm going to see the nodes of the selected diagram. For example, let's add a new diagram. I will call it Pirate Mission. I am writing code actually while I'm building a diagram, so Pharo asks for my name. So I have a Pirate Mission. Now I will start adding some boxes. I can, for example, add a new class box. And this is a clean, empty class box. And I can start describing it. For example, I can say that Pirate has, for instance, variables. Some coins, oh my, this keyword, and some items. When I save what I wrote here, it reflects on the actual diagram. So this pane here is useful for describing each diagram node, and while I'm doing this, I am describing the whole diagram. I won't use this box actually, it was just to show you how to add a new empty class box. Maybe it's more useful to play with these other options. For example, add a new class box from existing class in the category I am documenting. So here is a list of classes that I can document in this category, and I will choose Pirate. So here I can see the class box of Pirate with its instance variables and instance methods. And I can also see that in the description. I can also see the position of this diagram node in the screen. So even the position I can specify by code. So well, I have a Pirate, and now I'm going to add. I'm going to use this just as an example. A sheep. Maybe this option is more useful when I want to add in the diagram a class that is not in this category, but it plays a role in what I am trying to communicate in this specific diagram. So I have a sheep. I'm going to put that here. So I can say to the sheep right now that it has lots of pirates labeled as pirates. So an association appears relating the sheep and the pirate in the way I told. I can, if I added an association here, a label representing the variable of that association appears. So maybe it's not necessary anymore to say that the sheep has the instance variable pirate. Once I do that, the instance variables line disappears, just to be more comfortable. Okay, so now I can still add some things. For example, I can add a mission. Every sheep will have a mission. I will put it right there. And I have several classes of missions. For example, I have, you saw, the threshold quest, and I have becoming a legend, and also I have the robbery. This will be a little uncomfortable, but I can say, for example, that the treasure quest inherits from mission, and becoming legend also inherits from mission.
Why does it do it automatically?
Because I chose to do it automatically. You would prefer to first describe the whole diagram node and then just say update?
I'm saying if you already have the classes.
Why doesn't it?
Yes.
Oh, okay, I misunderstood. Okay, that's a great question. And I will wait for the ending of the demo because we are talking about that. Well, it's robbery. But yes, I wanted you to notice that maybe some things can be automatic.
Can't you say self inside that main to refer to the robbery?
No. No, you can't. It could be cool.
No, I don't know.
It's an idea. No, the thing is that, let me show you, while I am doing this actually is part of the description of the whole diagram. So, I can go to Pirate's documentation, remember the empty, stupid class that we built some minutes ago, and I can see that now I have a method, Pirate Mission, that has the description of the whole diagram. So actually the name is local to this, not to the specific diagram node that I am editing. Okay. I will end up saying that the ship has a mission. Labeled as mission, of course. As you can see, I have some problems with the labels. It's so difficult to make this work. I am awful at maths, and this requires maths. A lot of maths. There you go. So now we can start playing, saying that I prefer to look the traditional way, with the subclasses at the bottom of the superclass, and well, just the way you like it. Okay, I wanted to show you something. Let me see. Well, no, I won't. So now, you see there are several kinds of arrows, like associations and inheritance arrows. We can also use uses. And this arrow, for example, that I can say that emission uses pirate. I think this is wrong, but let's see. I don't remember. And this is the another kind of arrow to say that an object of this class is used here, but there are no references actually to it. Okay, so we can play with a lot of things. I will show you a couple of more later. So, I hope it's a little more clear now about what this project is about. It's focused on communicating little ideas at once, little ideas at a time. The main goal is not auto-generating things, because the intention is that you think about what you want to communicate. You could, that is a problem. You could build a big diagram automatically, but it's actually difficult. But if you could, maybe you won't pay attention at what that diagram is documenting or communicating, because there will be a lot of boxes and arrows and everything, and an automatically generated diagram may not realize the ideas behind the code that it's diagramming. So when this is useful? It's useful when you document a project of your own. You know your project, you know your design, so then this is useful. You will be the one who is choosing what to communicate. And, well, of course, documenting a project that you already know, but it's not yours. Or sketching design ideas. You can build diagrams, and it's not necessary that you take the class boxes from code that it's already written. It's not so useful when you're trying to understand a project you don't already know, because of what I was saying before. At least right now, the features that auto-generate diagrams are very few. You can just auto-generate an inheritance diagram, and that's it. Well, there are some difficulties with this. Inferring associations between objects, it's not really easy because of the characteristics of Smalltalk, and that it's dynamically tagged. There are ways, of course, because other projects do it, but it's not really easy. And there's another thing that nice graph nodes that auto-position by itself are not easy to do either. I should study a lot of algorithms of other projects like GraphBees, or I think Moose also do it to position nodes. The ones that are working in this project right now are very funny and are very, very basic. I will show you later. And, well, what I was saying before, maybe an automatically generated diagram, it's not entirely useful because you're just showing the code that you already had, but in another form, with diagrams instead of the code itself. And the intention here is trying to use the diagrams to communicate a decision. So, there are some future cool features that could help with this problem. For example, generating diagrams from the execution of a block or a living object. That way, I could just, write a block and say, show me the class diagram of the things that are involved in the messages of this block. And then I can look into instance variables and the type of the objects that play in that context. Also sequence diagrams and also object diagrams. So having this set of diagrams could help me really to understand projects that are not my own and that are giant or difficult to understand. Okay, so now I will show you some implementation things of how this project was done. It's actually pretty boring. First of all, I want to show you the model of small UML. Here I have a couple of diagrams that show how it is modeled. I have diagrams. Here is the diagram. I removed a lot of methods that the diagram class has because I just want to show a context. Here is a very stupid functionality. It's just adding and removing nodes. And I can ask a diagram if it has a node for some model. And I was talking about this. What's a diagram node actually? It's the description. In the case of the class diagrams, it's a description of the class. I am not mapping the diagrams to the classes directly. The diagrams show description of classes. And the diagram node is the description of a class. So I can choose what methods I want to show from a class, or what relationships I want to show, and it won't be just the class as it is in the code. So a diagram node, apart from what we can see here, the instance variables and the instance methods, blah blah blah, also have a collection of relationships. A relationship that can be the association, the inheritance, the use, even the use of traits, etc. And a relationship also has the two diagram nodes that it connects. And there are lots of diagram nodes, different diagram nodes that understand different messages. For example, I want to say to an interface box which are their instance methods, but it's not useful for an interface box, a type box, to say which are its instance variables. I won't have instance variables there, but I will have instance variables, where is it? Here, in the class box. So there are different diagram nodes representing each thing that I want to show in the diagram. Here is an object node for the object diagrams that are partly implemented, but they are not done yet. Okay. And here is an inheritance diagram for the relationships. Notice that I could have included this in the other diagram, but, well, point A, you see that the screen is not infinite, so it would be uncomfortable. And on the other hand, here I want to focus on how the relationships work. And in the other diagram, I wanted to focus on how diagrams were structured. So here, this is a silly diagram because relationships have just a little template method that only changes the arrow that they will show in its view. And well, instance relationships also have the ability to know that if they are one-to-many or not. So well, there's not really much more than this. The model of small UML, it's small. Kind of, yeah, small. So I was saying here, there's no magic there. What are you hiding? Where do the diagrams actually come from? Well, it happened that during the project, I was learning Morphic, and it was very, very difficult. And when I started trying to draw arrows, I was mad. I was insane. It was so difficult to just draw a plain triangle. So I came up with a project that that was built on Squeak a while ago, that is named Connectors. So I said, yay, the magic is here. I can grab this and just have connections and nodes and everything. And I couldn't port it to Pharo. And it was pretty hard. And connectors, actually, as simple as it can sound, it's just for connecting two morphs. Like, I have one morph here, one morph there, and I want a narrow crossing among them. And it was a giant project. It was big, so I really couldn't decouple it from Squeak. So I didn't have a solution. And luckily, I came. I knew Fernando Libero, who is doing Gaucho. He's making Gaucho. I don't know if you know the project, but well, he actually tries to build code using another kind of user interface. Instead of the usual system browser that we know, he wants to be able to write the code by doing the UML model. You create a class box, and start writing the code there. And for saying that it has an association with another class, he draws an association, an arrow to the other class. So he, at some point, he came up with the same problem that I had. So I contacted him, and he said, I took just a little classes from connectors, and I am using them in Pharo for building Gaucho. So we started talking, and this little project came up, Minimal Connectors. It's for just connecting two morphs. It's silly, but it's not simple. It's not simple because if you noticed, the arrows here are also anti-aliased. The arrows that I started building at the beginning were horrible. These are nice arrows, and they already have the behavior to update its position while I drag nodes. It was very nice. I had to do a lot of adaptations to make it work with what I wanted. And so what is Minimal Connectors now? It's not really similar to the original connectors. It's not really similar to what Fernando used in Gaucho, but the intention is that now we start working on the same base. And also the idea is that everyone who needs to just connect two morphs and do games or other kind of diagrams or whatever can grab this little project and use it. Because it's a simple thing, and there was no solution for that. So here I have some diagrams that show how minimal connectors work. Here is where the real magic occurs. Let me show you this. And I really wanted to talk about this. First of all, here appear two other kinds of diagram nodes that we didn't see in the other examples. Here is an interface or a type box that is communicating that instances of these two classes have to be polymorphic, but they don't really share a superclass or a hierarchy. But I want them to understand those messages there. So it's nothing that I can map to something in the code, but it's something that I want to communicate, so I can add them to the diagram. And we also have here a trait diagram node. It's not what I saw in the way of drawing this, it's not the way that I saw it in the original trade paper, but I think this is pretty much simpler, and it's okay. So, we have the morph that we want to connect. This is a concrete morph. And instead of thinking about a hierarchy of connectable morphs, or composing them, like decorating them, I thought about the trait. I can add the trait to the morph I want to connect with other morph, and it has now the behavior that will allow it to connect to other morphs. And I didn't do it using inheritance because I don't want. Imagine that you already have all your morphs and your model and the hierarchy that you chose. I don't want to force you to change that. I don't want you to break that hierarchy just to make that this guy now is connectable. And composing smelled like it would bring trouble in the end. I wanted to have fun, so I also chose the trait because of that. The morph that you want to be connectable is composed with a connectable bound. This, unluckily, you have to add it to your morph class. As traits doesn't have state, I can't add an instance variable that forces you to do that. But I added here a method that says should be implemented. Okay, so a diagram morph has a connectable bound. Like I am a box, so I have 4 borders that have the behavior to connect with other morphs. So the really behavior of connecting is in the borders. And we have different classes of borders, like circle borders that I use for the object diagrams, and the boxes that I use for the class diagrams. And here you can see that the connectable bounding box has the actual connectable border. And it can be horizontal or vertical, and does its magic. And it also has some points. The borders have little points that are the connections, the head and the tail of the final connection. Here you can see that it's a point that in the end relates to the connection. And I don't really have much time, but the idea is that the connection does offer you a hierarchy that you can extend with your own connections. I think maybe that brings less trouble than offering a hierarchy for the connectable morphs. So as a conclusion, this was a Google Summer of Code project. This was the original proposal, to have auto-generated diagrams and edited through code, not through the browser I showed you. I wanted to have a website where diagrams could be built through code, and so smalltalk code is so easy that maybe other people who program in other languages could also use this website, not just us, because it's so easy, the smalltalk code that I showed you in the pane that was there to describe a diagram. And I wanted to do class diagrams and sequence diagrams. I actually wanted to do the sequence diagrams, not the class diagrams. But it's hard. And we wanted to be OB integrated. After the proposal was selected, my mentor said that the diagrams should be built by hand for the scope of the project, because it was very, very hard to do auto-generated complete diagrams. And they said that it would be very nice if they could be edited through with graphic tools and not just the code. It's nice. No website, only class diagrams, and still OB integrated. And these were the final results. Partially auto-generated diagrams, because I can extract the instance variables and methods and etc. from a class, and I can also, although I didn't show you, I can also build hierarchy diagrams. I have some graphic tools for diagram edition. I can at least drag and drop them. No website, class diagrams, and the base for sequence diagrams. No OB integration, luckily, yet. And after the Google Summer of Code, I did several improvements. I did a big refactor because at the beginning I only did everything for class diagrams, and when I wanted to add another class of diagrams, I had to make bigger and better abstractions. And object diagrams are almost complete. After today, what I want to do, the OB integration, something that everybody asks is, if a class changes, do I have to change the diagram, or there is some magic that tells me, hey, you updated a class, but you have to update your documentation also? Well, today that doesn't happen, and it would be nice to consider it. Complete object and sequence diagrams, a website, and the ideas that you can give me. This is where to get it, or you just search small UML and minima connectors in Quick Source. Well, I don't know. Do you have any questions?
Yeah, I agree that it's not a good idea to have automatic diagrams generation, but it's the question I asked you for. Is there any diagram that you created where you put a class and a superclass that you didn't put the subclass in relationship?
I'm sorry, I don't...
Si hay algún diagrama de clase donde tenías la clase y la superclase y no pusiste la relación de herencia.
Why would I want to do that?
Because my question was, why weren't you automatically creating that relationship when you have a class and a superclass?
Yeah, if you can insert automatically the inheritance relation.
Not today.
I think if the hierarchy is very large, you want to stop in some level and don't want to...
Yeah.
She loads each class and she can also load the arrow.
What I'm saying is, why aren't you creating the hierarchy relationship automatically? Because I think that that you put a class and a superclass, you will draw that relationship anyway.
Well, actually, the automatically generated hierarchies were just added last week, and were added just to build whole diagrams, not as a part of a diagram. But it's a feature that is partially done, so it could be added. You are right. You are right. Anybody else? Well, okay. Oh.
Yes. All the relationships were described by code.
Yes.
You didn't have time to do...
No, I dream about that. Yes, that's...
with a right-click menu.
Of course, yes. That's what I said, that there was some graphic tools to do this. Actually, the code pane is just there because of the relationships. Once I can draw the relationships, maybe I don't even have to put the code pane there. You can go to the code and maybe do some modifications there, edit it there or something, but in the browser you might not need it. Okay, so that's it.